What's up, Math Mob? We are back at it again with another video. This time, Unit 3, Lesson 4, Comparing Proportional Relationships. Man, sounds exciting, doesn't it? Anyway, alright, go ahead and get out your notebooks. Start your notes with the topic, Comparing Proportional Relationships, and our focus question, how do you compare proportional relationships represented in different ways? So go ahead and stop the video now and do that and the warm-up. And when you're done, you can unpause and we will go over the warm-up together. Okay, our warm-up. The equation y equals 4.2 could represent a variety of different situations. Write a description of a situation represented by this equation. Decide what quantities y and x represent in your situation, and make a table and graph that represent the situation. All right. The equation y equals 4.2 could represent a variety of situations. Write a description. Okay, first we'll write the description. So what could we say? Something is equal to 4.2 of something times something. So I guess I could say that, let's say every 1 second, a frog jumps 4.2 inches. So every second, a frog jumps 4.2 inches. Okay. Okay, so there's my description. Now, if I were to make a table of this, and we'll say that x is seconds and y is inches. In 1 second, frog jumps 4.2 inches. In 2 seconds, that would be 8.4. In 3 seconds, that would be 12.6, and so on. Okay, so now I'm going to graph that. I'm going to take that information from the table. So I have my description, and now I have my table. Now I can make my graph. Remember, this is my y-axis and x-axis. So my x-axis are seconds, and my y-axis is inches. Now, how am I going to decide what scale I'm going to use here? Am I going to go by ones, twos, what? Well, on my seconds, I have 1, 2, 3, so I could easily go 1, 2, 3, 4, 5, 6, 7. I'm going to do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So on my y-axis, I need to go up to 12.6 at least. If I go by ones here, I'm not going to make it, right? Because I'm going to end up with 10. I'm not going to be able to. I'm only going to fit these 2 points in. So I'm going to go by twos on my y-axis. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so now I'm going to plot these 3 points on my graph. So 1 second, I have 4, and I'm going to have to estimate, maybe about right there. 2 seconds, 8.4. So 2 is going to be 8. There's 9, so 8.4 is going to be about somewhere in here. And then 12.6, 3 is 12.6, 3 is 12, just a little bit, I don't know, maybe about right there. All right, so there is my graph. Let's see how close I was in estimating this. Pretty close. Pretty close there. Okay, so there is my graph, and I can see after 4 seconds, looks like I'm almost at 16. I'm actually would be at 16, a little more than 16, right? I could probably fix this a little bit better. Anyway, so there I have my words, I have my table, I have my graph. So I have 3 different representations of this situation here. And the equation for this is y is equal 4.2x. So I have words, I have an equation, I have a graph, and I have a table, all representing the same thing. And that's what we're going to do today. We're going to be comparing different representations of situations to see maybe how they're different or how they're the same. Okay, so first problem. Elena babysits her neighbor's children. Her earnings are given by the equation y is equal to 8.40 times x, where x represents the number of hours she works and y represents the amount of money she earned. Jada earns $7 per hour mowing her neighbor's lawns. So we have two people doing 2 different jobs. I wonder who makes more money. Anyway, let's find out. So go ahead and pause the video now. Work on these problems on your own, 1A, B, and C. And then we'll talk about what you did and how it compares to what I do. Okay, question A. Who makes more money after working 12 hours? How much do they make? Explain how you know. So we'll do Elena first. She's babysitting. She earns 8.4 times x, and x is the number of hours. So if she works 12 hours, I could just take 8.40, multiply it times 12. 8.40 times 12, got 0, 8, 16, 0, 4, 8. And I have 2 decimal places, 1, 2. So after 12 hours, Elena makes $100.80. So let's check Jada. Jada makes $7 per hour, so I'm going to multiply 7 times 12. So Jada earns $84 an hour. So after 12 hours, Elena makes $100 and Jada makes $84. How much more do they make? So how much more does Elena make? Well, I just find the difference. 100.80 minus 84. So it's 80. 10 minus 4 is 6. 9 minus 8. So $16.80 more is what Elena, how much more Elena makes, because that's the difference. What is the rate of change for each situation, and what does it mean? So the rate of change, how much does it change per hour, right? How much does it change after each hour? Well, this one is $7 per hour. That's her rate of change, $7 per hour. And Elena's is $8.40 per hour. So $7 per hour versus $8.40 per hour. And that is how much money they make, right? The rate of change is how much money they make per hour. It's their unit rate, their rate of pay. How long would it take each person to earn $150? Ooh, that's a tricky one. Okay, so if I put in my equation, 150 in here for y, because y represents the amount of money she earns. So if the amount of money she earned is 150, I could say 150 is equal to 8.40 times the number of hours she works. So 840 times something is equal to 150. So if I just divide 150 by $8.40, that'll give me the number of hours. So the number of hours is equal to 150 divided by 840. I'm going to do that on my calculator. So 150 divided by $8.40 is 17. I've got this long decimal here. So $17 or 17 hours, right? This X is the hours. 17.857140. I'm just going to round that. I'm going to say 17.86 hours. All right. So it would take her 17.86 hours to earn that. So almost 18 hours for Elena. But what about Jada? So Jada, to make 150, that would equal 7 times the number of hours she works, or 7 times X, right? So I could do the same thing, divide by 7, 150 divided by 7, then the hours would be, with this, 150 divided by 7 hours, or $7 per hour, nope, divided by 7, it's 21 point, I'll just say 21.43. So we can see, since Jada earns less money per hour, it takes her a little longer to reach $150, right? It takes her a little bit longer than Elena, because Elena makes $8.40 per hour, and Jada only makes $7 per hour, so it takes her a little bit longer to reach that 150 mark. All right, so let's do number 2. You can do number 2 on your own. Claire and Han have summer jobs stuffing envelopes for 2 different companies. Claire's earnings can be seen in the table. So this is how much money Claire makes. And Han earns $15 for every 300 envelopes he finishes. So that's how much Han makes. This is how much Claire makes. And we can see they're represented, how much money they make, in different ways, right? Here we have a word, here we have a description in words. And over here we have a table of values for Claire. So how can we tell who makes more money? Okay, so let's talk about these. Who would make more money after stuffing 1,500 envelopes? So if Han earns $15 for every 300 envelopes, there's a few ways I could go about this. I could go ahead and make a table, right? I could make a table, and here I could have money. Here I can have envelopes. So $15 for every 300. So if he stuffs 600 envelopes, he'll make $30, right? Because he makes $15 for every 300. Now, thinking ahead a little bit, I know that 300 is going to go into 1,500, right? Because 3 goes into 15. So let's go ahead and continue this pattern until we get to 1,500 envelopes and see how much Han makes. So 900 envelopes would be $45 every $15 for 300 envelopes. So I'm just going to go by 300 here. 1,200 envelopes would be $60. And here we are at 1,500 envelopes would be $75. So here Han makes $75 for 1,500 envelopes. Now let's see if we can do the same thing with Claire. So I'm going to take this and just move it a little bit up here. So that's Han. I'm going to remake Claire's table over here. So envelopes 400. She makes $40. And 900 envelopes. She makes $90. I kind of see there's a relationship here between number of envelopes and the money she makes. So if she stuffs, let's see, every 500 she makes $50, right? Because here's 500 more and here's $50 more. So if I say 500 envelopes, she makes $50. Okay, now I can see 500. If I just go up by 500s now, 1,000 envelopes, she's going to make $50 more, right? 500 every 50 envelopes, or 500 envelopes, she makes $50. So if I go up by 500, this is going to go up by 50. So now she has $100. And now if I go up to 1,500 envelopes, she's going to make $150. So, wow, Claire makes a lot more money than Han does. If I were Han, I'd go work for this company. So what is the rate of change for each situation? Well, we know that for every $300, every 300 envelopes, this is Han, this is Claire. So what's the rate of change? So it's $15 per 300 envelopes, right? So 300 envelopes, they make $15. Or we could rewrite it this way. Let's rewrite it this way. $15 per 300 envelopes. And over here we saw that it's $50 per 500 envelopes. So I mean, we know that Claire makes more money, but it's not so clear here, is it? So I wonder how much money they make for one envelope. That would be a good way to compare, right? How much do they make for one envelope? So this is $15 for 300 envelopes. So if we divide this $15 by 300, that would tell us how much per one envelope, right? So how much money do they make per one envelope? So here we have a proportion set up. This is a ratio, right? This 15 to 300 is how much per one? So we know when we look at proportions like this, these cross multiples are going to be equal to each other. 15 times 1 is going to be equal to 300 times something. So we could just divide. 15 divided by 300. Right? 15 times 1 is 15 is going to be equal to 300 times whatever this is, times x. So if we divide by 300, that'll tell us what that x is. Oops, not 1300. 15 divided by 300. So I'm just going to get my calculator out and go 15 divided by 300 is 0.05. That's 5 cents per envelope is what Han makes. 0.05. So Han makes 5 cents per envelope. And let's do the same thing with Claire. 50 divided by 500. She makes 10 cents per envelope. So we can see here that Claire makes twice as much as Han, right? And we can go back to the table over here and we can see that for 1,500 envelopes, Claire makes twice as much. 75 times 2 is 150. So Claire makes twice as much per envelope. So this unit rate, this rate of change, we could say that, well, we know that Claire gets paid more per envelope. This rate of change, Han makes 0.05 per envelope. Claire makes 0.1 or 10 cents per envelope. And we can see this rate of change is higher, right? So Claire gets paid more. And we could see Claire gets paid more here because they make the same envelopes. Claire gets paid more. But now we have some more evidence of that. We have their rate of pay, right? 10 cents per envelope, 5 cents per envelope. That's a good thing to know, because now we can figure out how much money they make for any number of envelopes. Okay, number 3. Tyler plans to start a lemonade stand and is trying to perfect his recipe for lemonade. He wants to make sure the recipe doesn't use too much lemonade mix. And the lemonade mix is lemon juice and sugar, but it still tastes good, right? Because if you put way too much sugar, it'll be too sweet. If you don't put enough sugar in, it'll be too like bitter, maybe, right? Because lemon juice is pretty sour. Lemonade recipe 1 is given by the equation y is equal to 4 times x, where x represents the amount of lemonade mix in cups, and y represents the amount of water in cups. All right. So we have a lemonade mix. Maybe, I don't know if it's like powder lemonade or maybe it's concentrate lemonade. You see those frozen concentrate cans or the powder. It doesn't say, but we know this is the mix and this is the water. And you usually add water to lemonade to make it, right? All right. So let's see. What was it again? X represents the amount of lemonade mix. So this is X. And Y represents the amount of water. So this is Y. And the equation Y is equal to 4X. So the amount of water is equal to 4 times however many cups of mix. All right. So go ahead and finish question ABC on your own, and then we'll come back and check it. Okay, if Tyler had 16 cups of lemonade mix, how many cups of water would he need for each recipe? So lemonade mix is X, right? So we're going to replace the X with 16. So Y is equal to 4 times 16. And get my handy dandy calculator. 4 times 16 is 64. So 64 is equal to 4 times 16. So he would need 64 cups of water to use with 16 cups of lemonade mix. What is the rate of change for each situation, and what does it mean? So if we had one cup of lemonade, how much water would we need? We need 4, right? So right here is our rate of change. When X is equal to 1, this is our rate of change. Our rate of change is 4. So our rate of change is 4, but what does it mean? It means for every cup of lemonade mix, we need 4 cups of water. That's our rate of change, 4. 1 cup of lemonade mix, 4 cups of water. 2 cups of lemonade mix, 8 cups of water. 3 cups of lemonade mix, 12 cups of water, right? That's our rate. That's our rate of change. If I made a table, and went 1, 2, 3, I would have 4, 8, 12. And here's a continuation of that. If I went all the way up to 10, I would need 50 cups of water. Is that right? Oh, that's recipe 2. No. If I went that's for recipe 2. Because in recipe 1, if I went up to 10 cups, I'm going to multiply this times 10. I'm going to multiply this by 10, this times 10. I'm going to get, I did it again, 50. It's going to be 40 cups, right? 40 cups of water. So we can see that here with 10 cups of mix, I have 50 cups of water. 10 cups of mix here, 40 cups of water. Which one's going to be stronger? Anyway, so the rate of change for this is 4, but what's the rate of change here in lemonade 2? Well, here I can see that if I have my 4 divided by 1 is 4. 8 divided by 2 is 4. 12 divided by 3 is 4. That's my rate of change, right? That's how I get my unit rate. I could do the same thing over here. 50 divided by 10 is 5. Is 65 divided by 13 5? Let's see. 65 divided by 13 is 5. 105 divided by 21, is that 5? It should be. 105 divided by 21 is equal to 5. So there's my rate here. There's my rate here. So if I use the same equation here, y is equal to 5 cups of water for every cup of lemonade mix. So Tyler has a 5-gallon jug which holds 80 cups to use for his lemonade stand. 16 cups of lemonade mix. Which lemonade recipe should he use? Good question. So we have 80 cups of... It holds 80 cups total, right? Holds 80 cups total. So we need... Ooh, that is a good question. Oh, he has 16 cups of lemonade mix. So if he has 16 cups of lemonade mix, 5 times 16 here for recipe number 2, 5 times 16, this is why knowing that equation and knowing the rate is good, because now we can do 16 times 5 is 80. So we need 80 cups of water, right? 80 cups of water is equal to 5 times 16. So for 16 cups of mix, we use 80 cups of water. Is that going to fit in an 80-gallon jug? Or 80-cup jug? Well, that's just going to hold the water, right? We won't have room for the 16 cups of mix. That is just enough to hold the water, right? This is the water. This is the mix. The water plus the mix together is going to equal 96 cups. So we need something to hold 96 cups for this recipe. But let's check this one. That's something to think about, right? That's why I said it was a good question, because it looks like this would be right. We got 80. We have an 80-gallon jug, but remember, that's just the water, not the water and the mix together. So it must be this one. Let's check. So he has 16 cups of lemonade mix. So 16 times 4 is equal to what? 4 times 16. 4 times 16 is 64. So 64 cups of water and 16 cups of mix. So this together, 64 plus 16 is 80. So now we have the water and the mix together is equal to 80. So Tyler should use recipe 1 if he only has a 5-gallon jug that holds 80 cups. That's 16 cups of mix and 64 cups of water. All right, let's take some notes. So what information do you need to compare two different proportional relationships? So how did we compare? What is the main thing we used to compare? What did we use to compare these two situations? What did we use to compare these two situations? Or what is the main thing that would be good to find? So one thing would be to find the rate of change. Or unit rate. Right? How much did something change? So how do we find that? We can write equations, right? We can write in equations. for the situation. And if it's proportional relationship, then we know the equation is going to be y is equal to mx, and this will be our rate of change. Oh, that looks familiar, doesn't it? Rate of change is also, whoops, we could find this rate of change. That would tell us who made more money, or how much water we needed, right, per mix. So rate of change, also called the slope, right? That we know that's the slope from our previous lesson. So the rate of change or unit rate all mean the same thing. Finding the rate of change or unit rate is really powerful, because then we could find any amount. So how do we do that from a table, right? We could divide y divided by x is going to be equal to our unit rate. So what was an example? Let's use this example here. 50 and 10. So 50 and 10, let's see, 120. So we could take these. 50 divided by 10 is equal to 5. 100 divided by 20 is equal to 5. So here's our unit rate. That's our unit rate, or our rate of change, or our constant of proportionality, right, from last year. That's how we found the constant of proportionality. That's all the same thing. All the same thing here. This m is the constant of proportionality. It's the rate of change. It's the slope. All different words for the same number. Okay? What words tell you that there's a constant rate of change? Well, what are some of the things that we looked at here? This one really doesn't say anything. It's not words, right? So what were some words here? For every, right? $15 for every 300. That tells us our rate. $15 for every 300. So we could say for every. What's another one we used? Let's see, were there any here? That was for every. Let's see. This one, she earned $7 per hour. That was her rate, right? $7 per hour. So let's add per in there. Are there any more? For every, per, like miles per hour? That's a unit rate. $7 per hour. $7 for every hour. What's any other words you know? If you think of any, go ahead and put them in here. But these are some common ones: for every and per. Okay, that is all I have for you guys today. Have a great day, and I'll see you guys next time. Don't forget to like, comment, and subscribe, and hit that little bell notification to know when I have new content coming out. See you guys.